It's called the Wafer-Scale Engine 3. It has 4 trillion transistors. It's roughly the size of a dinner plate. And a company you've probably never heard of just used it to convince OpenAI to sign a $20 billion check. This is the story of Cerebras and why the biggest chip in the world might just win the AI race by refusing to play by the rules. Every chip you've ever owned starts life the same way, as a big circular wafer of silicon. Manufacturers etch dozens, sometimes hundreds of identical chip patterns onto that wafer, then slice it apart like a pizza. The catch? Now you've got hundreds of separate chips that need to talk to each other. And that conversation, chip to chip, board to board, rack to rack, is slow. It's the single biggest bottleneck in AI computing today. Cerebras looked at that trade-off and said, what if we just didn't cut the wafer at all? What if we didn't cut it at all? That question changes the economics of AI hardware, because every wafer that stays whole can unlock far more compute than a sliced one. So here's the WSE3, Cerebras' third-generation flagship chip, built on TSMC's cutting-edge 5-nanometer process. That's not a typo. That's not a bit bigger. That's an entire wafer, functioning as one processor, roughly 57 times the surface area of an H100. Packed onto that silicon, 4 trillion transistors and 900,000 individual AI-optimized cores. Now, remember that yield problem we talked about? Cerebras solved it with a clever trick. They made each core tiny, about 1% the size of a core on an H100, and built in massive redundancy. If manufacturing finds a defect somewhere on the wafer, an on-chip routing fabric just detects it and reroutes around it to a spare core. The company claims this gives them roughly 100 times better defect tolerance than anyone thought possible for a chip this size. That's the engineering breakthrough that makes the impossible chip actually manufacturable. Every modern GPU has a dirty secret. The processor and its memory live in different places. Data has to travel off the chip, across a physical connection, to reach memory, and that trip costs time and energy, every single time. The WSE3 packs 44 gigabytes of SRAM memory directly onto the wafer itself. No trip outside. For context, an H100 offers 3.35 terabytes per second of memory bandwidth. The WSE3 is roughly 7,000 times faster on this metric alone. The internal interconnect fabric moving data across all those cores adds another staggering number, 214 petabits per second. So they built a companion system called MemoryX that decouples memory from compute. A single WSE3 can reach out to up to 1.5 petabytes of external memory, letting it ingest genuinely enormous, unpartitioned models, theoretically up to 24 trillion parameters, without needing the complicated multi-GPU slicing tricks everyone else relies on. Engineers use frameworks like Megatron LM or DeepSpeed to manually fragment the model, and that fragmentation is genuinely painful. A 175 billion parameter model can require around 20,000 lines of specialized distribution code just to run across a 4,000 GPU cluster. On Cerebras, because it's one giant contiguous piece of compute, that same model needs roughly 565 lines of standard code. That's not an incremental improvement. That's a different category of problem. Their compiler, Csoft, plugs directly into PyTorch and TensorFlow and just maps the model spatially across all 900,000 cores automatically. Their numbers for the 400 billion parameter Llama 4 Maverick model came in at over 2,500 tokens per second per user, more than double what NVIDIA's flagship Blackwell system could manage, precisely because there's no off-chip memory trips slowing things down. The headline name is OpenAI. Cerebras signed a multi-year compute agreement worth $20 billion, running through 2028, where OpenAI will deploy up to 750 megawatts of Cerebras inference infrastructure, with room to expand to a full 2 gigawatts. As part of the deal, OpenAI could end up holding roughly an 11% equity stake in Cerebras. That is about as strong a validation signal as you can get in this industry right now. A third one, Condor Galaxy 3, is under construction. planned as 64 CS3 systems delivering 8 exaflops of AI compute. It's not Cerebras versus the cloud giants. It's Cerebras plugging into them. In May 2026, Cerebras went public, and it was the largest tech IPO of the year, raising $6.4 billion. They priced shares at $185, way above the original $115 to $125 range. And on the day itself, the stock rocketed to an intraday high of $386. That briefly valued the company near $85 billion, or roughly 99 times its guided 2026 revenue. That is an eye-watering multiple. Reality set back in fast, though. By mid-2026, shares had settled around $200, putting the market cap closer to $45 to $50 billion. Still a massive number, just not quite internet-breaking territory anymore. And the actual revenue behind that valuation? $510 million in FY 2025, up 76% year over year, with guidance of $855 million to the $865 million for FY 2026. Hardware sales are still the majority of revenue today, but the company is visibly pivoting toward a cloud and services model, compute as a service, which now makes up 43% of the business. Now, let's play devil's advocate for a second, because no story this exciting is risk-free. First, customer concentration. Roughly 86% of Cerebras' 2025 revenue traced back to UAE-linked entities, G42 and MBZUAI. If that relationship sours or export policy shifts, that's not a small dent. That's the foundation of the business. Second, profitability. Cerebras is still burning cash hard. They're guiding for operating margins between -28% and -32% for FY 2026, and they're working through a $3.3 billion cash reserve to keep building out data centers globally. The OpenAI deal is a huge vote of confidence. But it also means Cerebras now has to actually deliver megawatts of infrastructure at scale on schedule, which is a very different challenge than shipping impressive chips to a handful of sovereign clients. So, revolutionary architecture, genuinely elite customers, a rocky but headline-grabbing IPO, and a balance sheet that says high risk, high reward in flashing letters. Cerebras isn't trying to out-NVIDIA. They looked at the entire premise of how chips are built, decided the premise itself was the bottleneck, and bet the company on breaking it. Whether that bet pays off depends on things way outside the silicon, geopolitics, cash burn, and whether biggest chip in the world can turn into most profitable chip in the world. Cerebras is building the new stack for AI inference, from the wafer to the data center, and the next era of compute will be won by those who can scale the entire system, from silicon to energy to software.